Okay, here's the key to quiz 1. So you can recognize it by the numbers in the Venn diagram. If your quiz has 0.245 repeating here, that's version 1. Okay, so first we'll talk about this problem with the Venn diagram. So here the left side has z, which hopefully you know by now is the integer set, and the integer set is all the negative whole numbers and all the positive whole numbers. Oops. And what else do we have here? Negative pi and pi, 8/4, which we, if you divide it out in a calculator, you'll find out it's just the same thing as 2. And n would be the set of natural numbers, which is the numbers from 0, 1, 2, 3 on up, the whole numbers. And there's 2, 4, 5, 2, 4, 5, 2, 4, 5 repeating. And there's the number 1 and fraction 3/5 and -5. Okay, so I'm just going to mark on here that just for us to remember that 8/4 is the same as 2, so I'll put 2 there. Okay, so where do these go? Well, there is the integer circle and there's the negative number circle. The second circle is labeled negative numbers. So anything that's a negative number is going to go inside the negative number circle. The only question is, does it go through the big part where it's only negative numbers but not integers, or does it go in the middle part, which means it's both negative numbers and integers? So so let's see if there is any number that is both negative, integer, and negative. So that would be like -5, right? -5 is both an integer because it's -5, it's a whole number, and integers include negatives, and it's also a negative number, so -5 would go in the middle. Negative pi, although it is not an integer, is a negative number, so we can put it in the negative number set. Okay, now pi without the negative cannot be put together in the negative number circle because it's not a negative number, and it's not an integer either because it's certainly not whole. So pi is outside the circle of both circles. Anything that is not negative and not an integer is going to be outside. So 0.245, 245 repeating, that is not an integer, it's not a negative number, so it's outside. 3/5, it's not an integer, it's not a negative number, so it's outside. Now the set of natural numbers is 0, 1, 2, 3, 4, 5 on up, and so we know that is integers. It goes into integers because the integers are basically the natural numbers plus the negative whole numbers, right? So the natural numbers fit in here, and then the number 1 also goes in here because it's an integer. It's a whole number, but it's positive, so it does not go in this little hole here. And remember, 8/4 is the same thing as 2, so it goes here in the larger part of the integers because it's not negative. Only the negative whole numbers would go in here, and there's only one, it's -5. Okay, so that's the Venn diagram. Let's go to the rational numbers. Okay, so we have here 4 numbers, and we're supposed to figure out if these are rational. Well, remember that the opposite of rational is irrational, and irrational numbers are basically any number that goes on forever in terms of decimals and never repeats and never terminates. Now, this number here, 1.265656565, repeating forever, it does repeat. It does go on forever, but it repeats. So if it repeats, remember you can use that math trick to convert it into a fraction, and converting into a fraction means it is a rational number. So 1.2656565 repeating is a rational number. Okay, 3.5 over 2 does not look like a whole number fraction, but you can easily change this into a whole number fraction by multiplying the top and the bottom by 10. if you multiply the top and the bottom by 10, you could change this into 35 divided by 20, right? So it could turn it, you can easily turn that into a fraction, okay? Square root of 3 is an example of an irrational number which never repeats, never terminates, goes on forever. Okay, just because you add 1 to it doesn't change anything, right? Square root of 3 is going to be like 1.7, I don't know, 312, something going on forever. If you add 1 to it, it's just going to be 2.7312 going on forever, okay? Basically, whatever math operation you do to an irrational number, it's going to be an irrational number unless you just like do something like square root of 3 minus square root of 3, and then of course that's going to be 0, okay? Or maybe like square root of 3 divided by square root of 3, and that's going to be 1, for example, okay? So like anything divided by itself or anything subtracted from itself is going to be 0 or 1, so maybe that's one way you could get rid of a irrational number, but that's pretty much the only way, okay? So negative 2 pi is, you're just multiplying an irrational number by 2, it's still going to be an irrational number, so that is not a rational number, okay? So there's only two rational numbers. There's 1.265, 65 repeating, and 3.5 divided by 2. Okay, the others two are irrational. Okay, let's move on to the next one. The next one is to round to three significant figures, 69,371. So three significant figures means you want to keep the first three, so 6, 9, and 3. Okay, the 7 one you want to get rid of, but the one you're going to ignore completely. You're just going to throw it away. Okay, the 3 or the 7 we need to look at before we discard it. Okay, because the 7 is going to influence the 3. The 3 next to it is either going to stay 3 or it's going to go up to 4. And since 7 is greater than 5, that 3 is going to go up to 4. So it's going to be 694 instead of 693. Now the 7 and 1 that we threw away, we need to hold its place, so we put in 2 zeros for place value, and that's why we end up with 69,400. Make sure you remember to put those zeros in, otherwise it's just going to turn into 694, which is not at all the same as 69,371. Okay, going to the next one. We have 0.3949. Okay, this tricked a lot of people. A lot of people, when they discard the 4 and the 9 because it says to keep two decimal places would be the 3 and the 9, right? What do you do with the 9? Does the 9 stay a 9 or does it go up to 0? Well, a lot of people went and looked at the 9 and then rounded the 4 up to 5, and then that rounded the 9 up to 0, and this rounded up to 4. Okay, but actually the 9 here is going to be totally discarded. The 4 here is going to get looked at to see if it influences 9. Since 4 is less than 5, it will not raise the 9 up. So this is actually 0.39 with, you know, you're not going to round it up because of the 4. Okay, you don't look at the 9, you only look at the 4. Now we convert the two numbers below to a fraction. Okay, so the first one is pretty easy. You just take 1.532 and you divide it by 1. Okay, and now it's already a fraction. Well, it's not a whole number fraction, and we want a whole number fraction. So we need to change the top and the bottom by whole numbers. Well, we have 1.532 on top. If we multiply it by 1,000, then that is going to make that a whole number. So we're going to multiply the top by 1,000, we're going to multiply the bottom by 1,000, and we're going to get 1.532 divided by 1,000. Okay. Now remember that you can you can make your calculator do this automatically. If you're not good at this in calculating, all you need to do is turn your calculator into the right mode. Let's see if I can do that here. It would be maybe this mode, N over D. Okay, so that would be, let's try to do that. Okay, so now maybe whatever I put in, it's going to print out as a fraction. So I'm going to do 1.532 divided by 1. Well, no, that didn't work. Okay, so I need to figure out how to do that later. Let me see if I can see. Yeah, there's a setting here somewhere to make it into a fraction all the time, but oh, I found it. Here it is. There it says fraction. So we'll choose fraction, and then we get out of that, and then now we'll go 1.532 again, 32, and there. It actually reduced it. Like 1,532 divided by 1,000 reduces to 383 divided by 250, and that would be okay too. So that would be an okay answer, calculated with your calculator. Okay? Now what about this one where you have 1.532323232 repeating? Now here we're going to use that math trick where we're going to shift 1.532 over to the left 2 places by multiplying times 100, and then we subtract itself, and then we're going to get 99x on the left, and then we're going to get on the right 151.7. So we got 151.7 divided by 99, and that changes to 1517 over 990. Okay, and that is that trick that we used in a lot of the worksheets. Okay, number below has 5 significant figures. Convert to standard form. Okay, so we have 653,200, okay, and even though it looks like this number has 1, 2, 3, 4 significant figures, I'm saying it has 5, so that means that the first 4 are significant, yes, and the first 0 is also significant, okay, so but the second 0 is not, the last 0 is not significant. Now how do you show that in scientific notation or standard form? We're going to put 6.5320, so we show the first 0 in scientific notation, and to convert that to 653,200, we need to put 10 to the 5th here. Let's check that. Okay, 10 to the 5th moves the decimal point over 5, so it would be 1, 2, 3, 4, 5, so that would be 653,200, okay? And you could also do that with your calculator if you prefer, so you could put it into so that it outputs in scientific notation. And let's go down and change that other thing that we had changed before to decimal or auto. Okay, and then get out, and then we're gonna do 653200, enter, and there it comes out 6.532 times 10 to the 5th. The only thing it doesn't give you right is the significant figures. You have to do that by hand because calculators do not figure out they don't figure out significant figures. Okay, so that was the regular part of the quiz, and now we're just going to do the bonus. Okay, now this is just calculator work here. So we're going to input 3.2, and remember from other videos that to put in scientific notation, use second comma, which is the EE. So with 3.2 times 10 to the negative 8th, and you got to use negative, not the minus sign, and you divide by 9.3, and then we put EE, and then we put negative 2 here. Okay, and then what do we get out? We get 3.44 something something times 10 to the minus 7th. Okay, so that's our answer, which we have here. Now, how many significant figures? Well, it tells us to give 3 significant figures. So it's 3.44086 blah blah blah, but you're only going to keep 3.44 because the next number 0 is not going to cause the 4 to round up. Okay, so that was that one, and this one, the addition one, it's just the same thing. You go 3.88, and this video might get cut off because it's getting close to 15 minutes. It's just you go plus, and then you go 2.1. So it's just calculator work. Okay, so 3.901 times 10 to the 5th, but I asked for 3 significant figures, so you cross out the last one. It's not going to affect the 0 because it's less than 5. Okay, so these 2 bonus questions were just, can you use your calculator to figure it out, and then can you round to get the right number of significant figures.